So, hello everyone. In the last class, we have studied Euler's theorem of first order derivative and second order partial derivative. Then we have solved few sums on based on Euler's theorem. We have verified Euler's theorem, and now then we have seen total differentiation of z, which depends on x and y. Now we are having differentiation of composite functions. So, let u is f of x y, and this x and y are depending on some other variable t. That means u depends on x and y depends on some other variable t. So, indirectly u is also depending on t. So, there we are calculating del u by del t. It is like this: u is depending on x and y, but x and y are depending on t. So, we can say u is also depending on t. So, we can say du by dt equals, now u is a function of x and y. So, u depends on x, u depends on y, but this x depends on t and this y also depends on t. So, from here we are getting this formula del u by del t. Please note here where we are using d and where we are using del. When it is depending on only one single variable, we are using d, and where it depends on more than one variable, we are using del. For example, u depends just on t. We have u, x, y, and they are depending on. So, u is depending on one variable t, that is why we have used du by dt. But this u also depends on x and y. Now, here u is depending on two, x and y, that is why we are using del u by del x, del u by del y, and again x, y, they are depending on one. So, we have used dx by dt, dy by dt. That is why be very careful when you are using this d and del operator. We are using d when our variable depends, our dependent variable depends on one independent variable, and we are using del when it depends on more than one variable. Since u is depending on x and y, we are using del, but x and y depends on one, that is why we are using just d. The same thing applies here. Here z is depending on x and y, but x and y are depending on u and v. Now, z is depending on x, y, and x and y depends on u, v. So, indirectly z also depends on u, v. Now, z is depending on more than one variable, that is why we are using, once we are using del z by del u, and once we are using del z by del v. Also, z depends on x and y. So, del z by del x, del z by del y. X depends on, for the first case, x and y depends on u, therefore del x by del u by del u. Here we are using everywhere we are using del only, because z is also depending on 2 and x is also depending on 2, y is also depending on 2. So, we will use just partial derivatives. The same thing is for v, del z by del v, it is z is depending on x and y is depending on v. Now, the third case, z is equal to f of x y and y is depending on x. Now, only y depends on x. So, since z depends on x and y, but x and y depends on only x. So, z is indirectly depending on x, that is why we are using its u, in place of z is u, I guess. No, let it be u. So, u depending on x, y, and x, y depends on x. So, we can directly say u is depending on x. So, we are using del u by du by dx. It is depending on only one variable, but u also depends on x and y. So, it is x and y depends on x. It is given y depends on x. So, y depends only on x. So, dy by dx. We can always formulate the formulas by our own. Just we have to be very careful where we are using d and where we are using del. Then the last case, here u is depending on x, y, x is r cos theta, y is r sin theta. Here we can have these 4 cases. In the last case, we have u is equal to f of x y, where x is r cos theta, y is r sin theta, and we are having these 4 formulas here. Here see, you can be depend on r, you can depend on theta, you can also depend on x, you can also depend on y. Therefore, we are having these 4 formulas there. We may use whatever is required as per the sum we have to solve. Now, let us solve few sums based on this. Let the first one be z is equal to x square y plus y cube, where x is equal to log t and y is equal to e raised to power t. See, we have to decide which formula has to be used where. First we have to see z is depending on x and y depends on t. So, z is indirectly depending on t, so we have to use dz by dt. D because z is depending on only t, only one single variable. It is, and it also depends on x and y, and x and y depends on only t, so we will use here d. So, it is dx by dt, dx by dy by dt. Now, z, derivative of z with respect to x will be 2xy, y cube derivative with respect to x will be 0. Then derivative dx by dt log t is 1 upon t, plus derivative of z with respect to y will be x square plus 3y square. With respect to y we are doing x square is constant, y derivative of y will be 1 and y cube will be 3y square into dy by dt, e raised to power t derivative will be e raised to power t only. So, this is our, we are done with this. Let us solve one more. Z is equal to u square plus v square, where u is equal to 80 square, v is equal to 280. See, z is depending on u and v are depending on t. So, the z is indirectly depending on t. So, we have to again find del z by del t equals same formula, del z by del u, and u is depending on only t. So, du by dt plus del z by del v, and it is dv by dt. So, del z by del u, derivative of z with respect to u, it is 2u, du by dt, it is 280, plus derivative of z with respect to v, it will be 2v, and derivative of v, dv by dt, it is 2a. So, we are having 2 can be common, we are left with uat plus av. So, a can also be taken as common, so 2a will be common, actually 4 is common, sorry 4a, we will left with ut plus v. So, with this, these are few examples, we may solve few more examples in our next class, and then we will switch to the next topic. It is all for today, thank you.